How do you create a simple digital knob for electronics projects? Well, let's try a rotary encoder module. This is part 28 of the KEYESTUDIO 3701 sensor kit, the rotary encoder module. I'll use the fritzing software to show you how to connect everything. Here's what you'll need: an Arduino microcontroller, preferably the UNO version or similar, a 400 high point breadboard, a USB cable, the rotary encoder module, and 5 to 9 jumper wires. Place the rotary encoder module on the breadboard towards the middle. Connect the pin labeled G and D to ground. Connect the pin labeled plus to 5 volts. Connect the pin labeled SW to digital pin 7. Connect the pin labeled DT to digital pin 8. Connect the pin labeled CLK to digital pin 9. Now here is the real version. Here are the key features of this sensor module. The CLK pin stands for clock. This is one of the two main output pins, often called output A, that generates a pulse signal as you turn the knob. The DT pin stands for data. This is the second main output pin, often called output B, that also generates a pulse signal, but it is 90 degrees out of phase with the CLK signal. By reading the states of both CLK and DT pins and comparing them, your Arduino can determine both the amount of rotation and the direction of rotation, clockwise or counterclockwise. The SW pin stands for switch. This pin is connected to the built-in push button that is activated by pressing the rotary knob straight down. Next, grab the USB cable connected to the Arduino and then connect to your computer. We'll use the Arduino IDE software for programming the Arduino UNO. Upload the following 44 lines of code. Open the serial monitor and observe the values from the sensor. Rotate the knob and the position values should change. Press the knob into the board and it should illuminate the built-in LED. The code creates two functions that run one after the other in the loop section. The code is basically a combination of the state change detection.ino example and the button.ino example. If you happen to have the newer UNO R4 with the built-in LED matrix, then try the following code. You can display the values directly on the Arduino board. Once you get the hang of it, come back and join us for the next module.